Hey guys, welcome to the Chapter 12 test review. Let's go ahead and get started. Simplify the expressions by determining the sum or differences and show your work. Be very careful when it comes to the difference one because you're going to have to switch some signs in that second polynomial. Alright, with the first one, I have this quadratic or trinomial with a degree of 2, and I'm adding it to a binomial with a degree of 1. So you want to make sure you're going to add your like terms. So since I'm also adding, I really don't have to have those parentheses. You can go ahead and take those down and just look at everything all at once. And then make sure that we combine the correct like terms together. So I have a 5x squared here. Do I have a 5x squared anywhere else? Or I'm sorry, do I have an x squared anywhere else? And I don't, so he's going to go ahead and go in the front because I'm writing these in standard form, which means the highest degree goes first. Now I need to go and I have a positive 3x, and I look throughout the rest of my polynomial, and I see that I have an x right here. So these two terms will actually combine. It's a positive 3 plus a positive 4, so that's 3x plus 4x. Remember, your exponents do not change when you're adding. The only thing that changes is your coefficient. So 3 plus 4 is 7, so that would be 5x squared plus 7x. And then the last thing I need to do is go through and see what's common with this negative 10. So I've got a negative 10 and a negative 7. When I combine a negative 10 minus 7, that gives me a minus 17. So this would be a trinomial, is what we would call it. A trinomial, degree of 2. Degree of 2. And it is definitely in standard form because it's the highest degree first. Okay, now working down here, you got to be very careful because we've got this minus sign. So you need to distribute the minus sign over the entire polynomial. That's the first, second, and third term. So I'm going to go ahead and distribute him in, multiply each one. It's going to change all the signs. So I have 7x to the 5th minus 4x minus 2x to the 3rd minus 4x, and then plus 8. And that was because I went and I distributed that negative sign. Notice all the signs switched. It was a positive here, a positive and a negative. Now it's negative, negative, positive. All right, now we need to go through and combine like terms. I've got a positive 7x to the 5th, and I don't have another 7x to the 5th, so he just gets written right on at the first. And now let's go see what our next highest degree is. I have a 4x, but look right here, you've got an x to the 3rd power. He would be your next highest. And I'm looking at this, and I don't see anything in common, so he's just going to go ahead and be written next. Don't forget that minus sign. Make sure it follows him down. And I'm looking throughout the rest of the problem. I see I have a negative 4x and a negative 4x. These are like terms, so I'm going to go ahead and combine them. Minus 4 and then minus 4 again. So that's going to leave me with a negative 8x. And then last but not least, you've got this positive 8 at the very end, and I don't have anything else left. So the answer would be plus 8 at the very end. This would be a polynomial of 4 terms, or poly of 4. It has a degree of 5, and it is in standard form because it's leading with the highest exponent, and then it goes down. Determine the product of each set of polynomials and show your work. So product means we're multiplying. So I'm going to take this 7x to the 3rd power and I'm going to multiply it into this parenthesis right here. Whenever you are multiplying, that is when your exponents are going to change. So I have 7x to the 3rd times 4x. Well, 7 times 4, that's 28. And then x to the 3rd times x to the 1st. Remember, there's a 1 here, even though you don't see it. That would be x to the 4th. And then the next one is 7x cubed times negative 2. So that would be a negative 14 x to the 3rd. This time our exponent didn't change because the 2 did not have an exponent. Therefore, we didn't need to worry about changing the exponent. And this would be your answer. Okay, the next one, 3x squared times 11x squared minus 4x. Again, we are going to go ahead and distribute. 3x squared times 11x squared would be 33x to the 4th. And then 3x squared times negative 4x, well, 3 times a negative 4 is negative 12. x to the second times x to the first, that would be x to the third power. And that would be our final answer. 5x squared minus 1 times 3x plus 2. If you want, you could do the FOIL method, which is what I'm going to show you right here. That's the first. The first term would be 5x squared times 3x. That's the first thing I'm going to do, which is 15x to the third power. And then outside would be these two guys. That's our O. And that would be 5x squared times a 2. Well, 5 times 2 is 10, so that would be a positive 10x squared. And then we have negative 1 times 3x. That's our I, so that would be a minus 3x. And then for our L, we have negative 1 times 2, and that would be our L, negative 1 times 2, which is a negative 2. And now I'm going to go and look to see, do I have any like terms? I don't. So I'm just going to go ahead and write this in standard form. 15x to the third power plus 10x squared minus 3x minus 2. And that would be my final answer. You could do it that way, or you could do the box method. The box method was where we would go and you would put each term inside of a box. So this would be a 2 by 2 box. So we have there we go. Oh, one too many boxes. Sorry. Erase that one. All right, so in this little part right here goes the multiplication. And then I've got 5x squared and then the minus 1. And then on down here would go the 3x and then the plus 2. And then we fill in just like so. So 5x squared times a 3x. Let me make this a little bigger. There we go. That would be your 15x to the third power. And then 3x times a negative 1. That would be minus 3x. And then here we've got 2 times 5x squared. So that would be 10x squared. And then last but not least, we've got the 2 times the negative 1. That goes in this box. So that would be minus 2. And remember what I said, for the most part on the diagonal, you've got your like terms. But here we don't have anything like. We just have to make sure we have to write it in actual standard form. So that would be 15x cubed plus 10x squared minus 3x minus 2. And you can see we got the same thing that we got before, just using a different method. All right, let's go ahead and go down here. I'm going to go ahead and set up the box method for this one as well. And this will be a 2 by 3, so I'll need 6 boxes. So here, let me go ahead and make this a little bit bigger than I did last time. So I've got the multiplication, 10x squared, positive 2x, and the negative 3. And then I've got the 4x and the minus 3. And then this will all fill in. Right, so I've got my multiplication right here. I've got 10x squared, 2x, and a negative 3. Don't forget the negative sign. 4x and a negative 3. All right, let's go ahead and let's multiply. 4 times 10. That's going to give me 40. And then I've got x times x squared. That's going to give me x cubed. Because remember, we're going to add those exponents. There's a 1 here. So, sorry, that should have been a blue x cubed. All right, next we have 4x times 2x. Well, 4 times 2, that's going to give me 8. But then I've got x times x, so that's where the x squared comes in. All right, next I've got 4x times a negative 3. Well, 4 times a negative 3, that's a negative 12. And the 4 has an x, so the 3 doesn't, so it would just stay just x to the first or just x. Okay, now let's multiply that last column. I've got negative 3 times 10x squared, so that would be negative 30x squared. And then I've got negative 3 times a positive 2x, that would be negative 6x. And then I've got a negative 3 times a negative 3, and that would be a positive 9. And look here, I've got some like terms. I've got an x squared and an x squared, an x and an x. So that's all, those are all like terms. So when I go and I write them out, 40x cubed does not have a like term, so he stays right there in the very front. And now I have a 8 and a negative 30. Well, 8 minus 30 is negative 22. So that gives me negative 22x squared. And then I have negative 6x and a negative 12x. And when I combine those, I get a negative 18x. And then last but not least, I've got the positive 9. He doesn't have anybody to add with, and he just goes right there at the very end. And that would be our answer. Okay, now what we want to do is the opposite of what we were just doing. Now we're going to be factoring and not foiling, or not multiplying. So here we got to look at it and ask ourselves, do they have any common numbers? This has a 10 and a negative 15, and you know that 5 will go into both of them, so we write 5 on the outside. Do they have any common signs? Nope, he's positive, he's negative, so that would be a no. And then the last thing you want to look at is, do they have any common variables or common letters? They both have an X. This has 3 of them, and this has 2 of them. So the most they can both give is that 2. So that's what I'm going to go ahead and take out, 5x squared. And that means what I'm doing with those is I'm actually going to be dividing each term by 5x squared. So 10x to the third, I'll write it over here so there's more room. 10x to the third divided by 5x squared. Well, 10 and 5, that's going to give me a 2 because 10 divided by 5 is 2. X cubed over x squared, well, that's x times x times x over x times x. And what's going to happen there, these are going to cancel, and I'm left with just x. All right, now our minus sign. Then the next one is 15x squared divided by 5x squared. Well, you can see right away that the x squared is going to cancel all together because you've got x times x on the top and x times x on the bottom. Well, that cancels everything. And what you're left with is 15 divided by 5, which is a 3. So that would be our factored form of 10x cubed minus 15x squared. All right, the next one, you got to again ask yourself the question is, do they have a common number? I've got 6, 12, and 48, and 6 goes into all of those, so 6 will be making his way on the outside. Do they have a common sign? No, these two are negative, he's positive, so they don't have a common sign. Do they have a common letter? And they all do. They all have an X. This one only has 1, however this has 2 and this has 3. But the most that this one can give is a 1, so that's why it's just a 1 that makes it on the outside. And then you're going to go through each term and divide each term by that number on the outside. The 6's cancel, and this is x times x times x over x, which means one of the x's cancel, and I'm left with x squared. And then I have a minus sign. 12x squared divided by 6x. Well, just looking at 12 divided by 6, that's going to give me my 2. And then I have x times x over x. One of the x's cancel, and I'm left with just an x. So that would be 2x. And then now another minus sign. And then I've got 48x over 6x. Again, the x's cancel. 48 divided by 6 gives me 8. And then therefore my last one would be 8. And now I got to ask myself, can I do a what two numbers game here? Can I sit here and multiply to a negative 8 and get a negative 2 at the same time? So what two numbers multiplies to a negative 8 and adds to a negative 2? So let's think about that. Let's think of all the ways to get negative 8. We've got 1 and 8 and 2 and 4. It needs to be a negative 2. It has to add to a negative 2. So if I make this 4 negative and I add those two together, I'll get a negative 8 and I'll get a negative 2. So therefore I know that this isn't factored all the way. I've got to factor it one more time, and that would be x plus 2 and x minus 4. Now more factoring, except these are all going to be special products. So looking at this one right here, we've got 125x cubed. Remember when I told you if you ever see an x cubed, you have to think sum and difference of cubes. And what are sum and difference of cubes? But remember, we have to find little a and little b, and then square a, multiply a and b, and then square b. But the first thing you got to ask yourself is, what number do I take and cube it and I get 125? Well, 5 cubed is equal to 125. And if I take 5x and I cube it, I get 125x cubed. So therefore, little a is going to be 5x. So let me write that over to the side. Little a equals 5x, and little b is going to be whatever number I take and I cube and I get 8. And so that would be 2. So what I'm going to go and do is I'm going to put each one of these terms, everywhere I see an a up here, I'm going to put a 5x. Everywhere I see a b, I'm going to put a 2. So that would be 5x, 2, and now 5x quantity squared, and then 5x times 2 is 10x, and then 2 squared is 4. So this is not simplified yet because I still have to go in and do SOAP. Remember, same sign, opposite, always positive. So the same sign would be a minus. So I have a minus sign here. This is opposite, and that is always positive. And the last thing you need to do is simplify this right here. You need to apply that exponent. So I get 5x minus 2, parentheses 25x squared, plus 10x plus 4. And that is how you factor a cubic or sum and difference of cubes. Okay, the next one is 4x squared plus 4x plus 1. And remember with this one, this is a special product. We've got a squareable number in the front, or a perfect square in the front, and a perfect square in the back. So let's check to see if it actually is a perfect square trinomial. What is the square root of 4x squared? Well, that is 2x. What is the square root of 1? Well, that is 1. And now if I take those, 2x times 1 is 2x, but if I double it, I do get 4x. Therefore, I know this is a perfect square trinomial. This sign comes down here because it's got to be a positive 4x. So I put the sign here. You could either write it like this, or you could write it as 2x plus 1, parentheses 2x plus 1. Either way is fine. All right, the next one is 9x squared minus 4. And this is a binomial, is what you're first supposed to notice. It has a subtraction sign, and it's got squareable numbers in the front and the back. Therefore, you know this is most likely going to be a difference of squares. So square root 9x squared, and that gives me 3x. Square root 4, and that gives me 2. And remember, it's got to have opposite signs because it's got to multiply to a negative 4. So it would be the same thing over here, except one would have a positive sign and one would have a negative sign. And that would be the answer. All right, next one, 8x cubed plus 125. This is very similar to the sum of cubes. The difference of cubes is what we did at the very top. This one would be a sum of cubes. So we've got a, b, a squared, ab, and b squared. And this is the sign that we need, so it's a plus sign. So it would be same, opposite, always positive. All right, so let's go find little a. Little a is the number we take, and we cube it, and we got 8x cubed. So that would be 2x. And then little b is going to be the number that I cube, and I get 125, which would be 5. And now everywhere in the problem that I see an a, I'm putting 2x. Everywhere I see a b, I'm putting a 5. So that would be parentheses 2x, 5, and then 2x quantity squared. Try to remember that that's the whole thing is squared. And then 2x times 5, which is 10x, and then 5 squared, which is 25. Now let's go ahead and put our signs. Same, opposite, always positive. And the last thing we need to do is just make that 2x squared actually 4x squared. And therefore, sorry for the squeaking, guys. Therefore, that would be our final answer. Is there any more after that? Nope. A baseball infield is in the shape of a square within the bases and home plate. The area of this square is 8,100 square feet. What is the length of one side of this square? All right, so let's think about it. We've got the inside part of the infield. You've got your bases, here's second, first, third, and then here's home plate. And they say that inside this area is 8,100 square feet. So they want to know what is the length of one of the sides. So we know it's a square, and then area is length times width equals area, but in this case, our length and width are the same, so it would be side times side equals area, and in our area we were told is 8,100. Side times side is s squared equals 8100. All right, and then how we solve this? To get rid of that square, you have to square root both sides. And remember, whenever you square root, you're supposed to put a plus or minus in front of the radical. These cancel over here, and we're left with s equals 90. And it should be plus or minus. However, we're talking about a real life situation here, and you can't have negative feet. So our final answer would be s equals 90 feet. That would be the length of one of our sides of the baseball field, or of the infield. Determine the approximate solution to each of the given equations and show your work. So here we have a quantity being squared equals 71. So the very first thing we need to do is ask ourselves, what is preventing us from having k by itself? It has a positive 9 and that's squared. So let's go ahead and let's just get rid of that squared. So if I square root both sides, remember whenever we square root, we've got to put a plus or minus in the very front. So on the left, I get k plus 9 equals positive and negative radical 71. And then if you go and actually put in your calculator square root of 71, you're going to get that it's somewhat equal to 8.426. So we could round that to 8.43. And then now over here we've got k plus 9 equals plus or minus 8.43. Let's go ahead and get k by itself by moving over this positive 9. If it's a positive 9 over here, when we move it over to the other side, you have to undo it. So it's going to subtract 9 from both sides. So I get k equals a negative 9 plus 8.43. And what you have to do now is you're going to have to, plus or minus 8.43. So what we're going to do is we're going to split it into two separate equations. K equals negative 9 plus 8.43, or k equals negative 9 minus 8.43. And then you're going to go through and you're going to combine like terms, or simplify really is what you're going to do. Negative 9 plus 8.43, that would be k equals negative 0.57. And then over here, if I added those, I would get k equals negative 17.43. And those would be my two answers for this problem. All right, go ahead and let's go over to the next one. Again, same situation. You're going to square root both sides right at the very beginning. And whenever we square root, you've got to put a plus or minus in the very front. So on the left-hand side, I'm going to get 6 minus p equals plus or minus radical 47. And then now I'm going to go ahead and subtract 6 from both sides, because notice here he's a positive 6. I need to move him over here. So I do that by subtracting 6 from both sides of the equation. Minus 6 minus 6. That would be negative p equals a negative 6 plus or minus the square root of 47. I'm going to go over to the side and figure out what the square root of 47 actually is in my calculator. And when I do that, I get that the answer is 6.8556. 8556. So that's going to round to 6.86 basically. And then I'm going to go over here and I see negative p equals negative 6 plus or minus 6.86. But the problem is this p is not all by itself. He still has a negative 1 sitting here. So we've got to go through and change all the signs or divide everything by negative p. So he would be divided, and this would be divided. But this over here cancels out to just a p. Negative 6 over a negative 1 would be 6. And here I've got a positive and a negative. So dividing it by a negative would only just basically switch the signs. But you have both signs there, so it doesn't make a difference at all. All right, so now we have to separate into our two equations. We've got p equals 6 plus, here, I went ahead and wrote it out. So we've got p equals 6 plus 6.86, or p equals 6 minus 6.86. So here, if I add these two together, I'm going to get 12.86, or over here, if I subtract it, I'm going to get negative 0.86. And those would be my two answers for this equation. All right, number 7. Calculate the zeros. So that's what they want you to do. They want you to go and solve whenever it says calculate the zeros. So we've got to factor the equation first. So we got to ask ourselves, what multiplies to a positive 14, but at the same time adds to a negative 5? So this is kind of tricky because it's got to multiply to a positive 14, but add to a negative 5. So we've got 1 and 14, 2 and 7. If I made the 7 negative, I would definitely get the negative 5, but do I get the positive 14? No, you don't. So that's why at the very end of this problem it says, if possible, calculate the zeros. Well, for right now, you guys don't know how to calculate the zeros because the only method you guys know right now is the what two numbers game or the perfect square trinomial, and this is not a perfect square trinomial. So this is as factored as it gets, or this is as much as you can solve it for right now. So calculate the zeros, you wouldn't be able to. You would just put not possible. But very shortly you'll be able to, just not right now. All right, let's go over to this one. I've got x squared plus 3x minus 18. So it's what multiplies to a negative 18, but at the same time it has to add to a 3. So let's go through and list all of the factors of 18. We've got 1 and 18, 2 and 9, and then we've got 3 and 6. Right here you can see that if I put a negative sign here, that'll give me my 3, and it'll give me my negative 18. So this factors down to x minus 3, and then x plus 6 equals 0. So we're going to solve we're going to take both parentheses and set them equal to 0. And that's what I just did right here. X minus 3 equals 0, or x plus 6 equals 0. And I'm going to go through, I'm going to solve each one. I'm going to move my 3 over to the other side by adding it. So my first x, or my first 0, is x equals 3. Over here I'm going to minus 6 from both sides, so I get x to equal a negative 6. And those would be my two answers. You could always check by taking and plugging it back into the problem. 3 squared plus 3 times 3 minus 18, does that in fact equal 0? Well, 3 squared is 9. 9 plus 9 equals 18, and if you subtract it, you get 0 also. You could also do negative 6. Negative 6 squared plus 3 times negative 6 minus 18, does that also equal 0? Negative 6 squared is 36. 36 minus 18 minus another 18 does in fact equal 0. Okay, determine the exact solution for each radical expression, no decimals. So this is where we need to go ahead and write down our perfect square numbers. Okay, so that's what I did over here. I went on ahead and wrote down our perfect square numbers. Sorry, guys. Now let's go ahead and let's find those perfect squares inside of these numbers. So I've got a 45. 45 fits right in here. You know 36 doesn't go into 45. You could try 25, but it doesn't go into 45 either. It's not until you get down to 9 that 45 goes into it. So what we do is we separate it. We do the square root of 9 times the square root of 5, because 45 divided by 9 gave us that 5. That's where that's where we found everything. So here, I know the square root of 9 is the same thing as saying 3. So I know that that's 3, and then square root of 5 is not a perfect square, so he's just going to stay square root of 5. And that would be my answer. Over here, 275. I know 25 goes into it, so I know 25 actually goes into it 11 times. 25 times 11, and that would give me, this would turn into a 5 because the square root of 25 is 5. And then we have square root of 11 is not a perfect square, so he just stays square root of 11. Here we've got 44, and 4 does go into 44, so that would be the square root of 4 times the square root of 11. The square root of 4 is 2, and square root of 11 stays the square root of 11, so he just would stay 2 square root of 11. All right, last but not least, it's determine the roots of the equation. So it's the same thing as asking for the zeros. It's the same thing as asking you to solve. So that is where we have to factor, or first set it equal to 0, but it already is. Second step is to factor. So what two numbers multiplies to a negative 48, but adds to a negative 8 at the same time? So that's where we go through, write down all of the factors of 48. We've got 1 and 48, 2 and 24, 3 and 16, 4 and 12 right there. So it's got to add to a negative 8, so we make the 12 negative. And now I'm going to go over here and I'm going to put down my parentheses, x plus 4 times x minus 8, not 8, sorry, x minus 12. I was thinking of the answer. And then I'm going to make that equal to 0. Each one of those is going to equal 0 because we've got to solve. So I'm going to have x plus 4 equals 0, x minus 12 equals 0, and then I'm going to subtract 4 from both sides. I'm going to add 12 to both sides. And over here, that gives me x equals negative 4, or x could equal positive 12. All right, guys, I hope that helps you get ready for the test that's coming up soon. Thanks so much for watching, and good luck.